So, for the next talk of the day, Dennis Doomen is going to talk to us about slow reprojections in event sourcing. Well, what do? We make them faster, of course. Let's learn how.
Or just make them work. I mean, the projector. Yeah, sorry for this. It never happened to me before. It needs to happen the first time. I hope you also enjoyed the previous session because they really tied well. Actually, I think, but I don't remember, were we actually at the same training with Greg in 2013 somewhere? Because I was there with Yves Reinhardt. No. Oh, you were not. But we basically did the same thing, and of course we had this new hammer, and we were looking for a nail, and I actually found it with my client. So I've been doing event sourcing since 2013, I think. Yeah, it was even so. The training was even before that. And indeed, as Alexa said, for me, it's almost like it's just a tool. It's something that I've used. I understand the pros and cons. At least I like to think I understand them. I've seen the problems, the pains. I did my talks about this a couple of times over the last years. And this is about reprojections. So who am I? I'm Dennis. I'm from the Netherlands. You can hear that. Of course, now my clicker doesn't work either. Ah, yeah, see, that's me. Actually, it's 26 years. I'm in the .NET space as well. And yes, I've built my own event sourcing framework, of course. I just like to call it a set of building blocks. It's not a framework, it's a library. So you can use it and it doesn't use you. But I'm definitely going to check out yours because I didn't know about this one. I have a blog. I have coding guidelines because I'm obnoxious about coding style and quality of software. This is my little event sourcing library, which is only about projections, by the way. It doesn't try to solve all the other things because, as we discussed yesterday, typically you don't need a library to do event sourcing because every code base is different. And maybe, there's a BDD framework I worked on, and maybe you know this one if you're in the .NET space. You may have heard about this little library. Yeah. So let's start with a little bit of a ubiquitous language because I've also discovered that within the event sourcing community, as if that exists, but people use different terms for different things, and they can be very dogmatic about it, or passionate. Let's call it passionate. So I just want to make sure that I use the right terminology from my perspective. We have a projector. That's the thing that takes events and tries to create some kind of representation out of that we can use for querying. I'm trying to look at, does that actually resonate? We have something called a projection, which could be a persisted, but is a representation of those events in a form that's optimized for querying. Like instead of doing a group by on the database level, I see people making pictures like, okay, did I just establish a language now? Or just reinforce what we already know? But it's optimized for querying or for whatever you need that representation to be available. We have something called a stream, which is an ordered collection of events, usually associated with, in domain-driven design, the aggregate. So a set of entities that protect the functional invariance of your system. We have a commit, which is a bit sometimes called a transaction. It's a bunch of events that were persisted at the same time. They represent something that happened in the same transaction. Some people would say you would never have multiple events because everything is completely independent. I'm a bit more practical. Sometimes I cannot be puristic. And we have checkpoints, which is like a reference in this big ordered event store. You have all these events in history, and you would like to be able to point to a particular point. Whether that's a good thing, I'm not going to debate. Some people would say you should not even look at your event store as one thing that happened. But I like to think about it. We actually, I think you mentioned that, we actually analyzed a production issue that we would never have been able to analyze without event sourcing. We found, we have a pretty complicated domain where the product is installed on oil and gas on an oil platform, so disconnected. And we managed to use the event store to figure out what are the steps that somebody actually took that put our system in the wrong state. That was extremely powerful. But as our previous speaker said, every 2 years I have a new manager at my client and they start to challenge why we do event sourcing, all this complexity, everything would be much simpler if you put everything in a document DB. Yeah, sure. Sure. For me, event sourcing is, and I'm not going to stop talking about that, but it's a solution, as I said at the beginning, it has pros and cons. Yes, it has a certain amount of complexity, but if you have actually built production-ready enterprise class distributed systems using an ORM, or something like, you also have challenges and complexity, N+1, performance issues, or trying to optimize a SQL database both for reading and writing. I mean, at some point, you cannot add more indexes to the database. It's just different type of complexity. I really honestly believe that. But yeah, who am I? So why do we care about reprojections? Because they happen a lot. Unless your system is not successful and you don't need to change your functionality, but usually it is. There's a couple of things for reprojection. Maybe you want to fix a bug in the projection, which happens. Like you use a SQL database as your target, your column was too small, or something went wrong with like a nested table, N+1, sorry, a child collection was like duplicated or something like that. There's always things like that. And a lot of people, that's one of the downside of event sourcing, is that they don't see the direct correlation with what happens in a domain and how you project that. And sometimes people forget, like if they change something in a domain, if they change the event, they might not even realize they changed the event, which directly affects the projection. And they forget about that, and that's sometimes an issue, because in the past, you just updated your entity, and your ORM would solve all your problems for you. New features require new changes to projections. As I said, these are the two reasons. You can kind of do that in two ways, and I'll show you a couple of variants of that. An in-place upgrade, I have version 1 of my database, I have this projector, and then I roll out a new version of my code base, which produces, it stops version 1, it creates a version 2, not necessarily database, this is just an image to represent like a schema. It creates a second one, it reads from the old event store, reprojects everything, but the downside is you have downtime, because the old system is not usable until the new projections are running. If it's really fast, it's an option. But in reality, people don't want downtime. So what we use is something called out of place, sometimes also called blue-green deployments. So we have version 1 of the application. You deploy version 2. Version 2 is not reachable through the load balancer. It returns 5 or 3. Then the new version is basically starting to copy the events from the old version, copying them, one by one or by groups, doesn't matter, while the original system is still running. And that's the beauty of it, because yeah, you have an event store. It has like it shows you what happened in time. You can catch up to a certain point, like almost to the end, and then you switch over. Where the new application tells the old ones, now you need to become unavailable. You copy over the rest of the data, and then you switch over. Of course, you need to rebuild everything. The whole projection is being rebuilt, and that can take time. But it's beautiful, because from an end user perspective, you have no downtime. You just switch over and everything works. But yeah, we've done that since 2013, and yeah, this is the real problem, the rebuilding time. Yeah, as I said. So what options did we actually try or have been trying or are still working on? Well, there's plenty of options. The first one may sound very obvious, is that you make everything asynchronous. So you have the domain on the right side, you have your projections on the left side, and you just make sure that your projector is completely asynchronous. It observes what needs to be projected, and it can do whatever it wants to do. It can handle transient projection issues, which can happen if you have a SQL database beneath it. It can go as fast or slow as it wants, and the idea is that every projector either is asynchronous or synchronous, has pros and cons, but it can decide for itself. It can go as fast or it can use whatever technology it wants to become faster. Making it asynchronous could also mean that you're not going to rebuild it until the application starts, because it's data, it's a projection that you don't actually need right after the upgrade. You just postpone it. That's a completely valid option. The problem is, you can actually use a different storage as well, of course. The only downside is, you need this projector to have some way to track, like, where was it in the whole event store. You need this checkpoint that I just mentioned in my ubiquitous language. And not everybody likes that. I think it's called the all stream in some event store, I think. And I think there's some debates whether that's a good thing or not. But it's a valid option. I mean, every option has pros and cons. You need to realize that. There's no one option that's always, there's no one rule, of one solution that rules everything. The big problem with asynchronous projections is that the UI kind of needs to be eventually consistent. And like, I'm working on a code base that exists for like many years, 10 years already, and it wasn't designed for that. We're gradually trying to adopt it here and there, but the UI is just assumes that when you send a command from our TypeScript single page application to the domain, that when that command is processed, the projections are completely up to date, and you can just query it and display the UI. That is a change. It's not a difficult thing to solve. There's plenty of different solutions to solve that, but just something you have to be aware of. You can also project stream by stream. So what you're doing is essentially, instead of going through the event store event by event, you actually find an event in the event store. You look up what kind of aggregate is that, what entity does it belong to. You find all the other events for that one, query all at once, project that in memory, and then flush it to the database, which can be very fast, because then, let's say you have 1 million aggregates. You essentially have 1 million writes to your database. And I'm not as smart as Alex about the 2 millisecond thing, but it kind of avoids the problem. We're doing this as well. The flip side is your entities and your projections need to have a correlation. You need to have like a one-to-one relationship between your aggregate, your stream, and your projection. So again, this is an option for maybe a particular kind of projection. There's not a single. I mean, I don't know if you were at the PubConf thing yesterday, but I think one of the things I said, like, use the right tool for the right job, applies here as well. Different patterns solve different problems. Don't try to persist in one way of doing it. Some people would say, yeah, but it's too complicated for people. They get it. It's not that complicated. It's just a left fold. I don't even know what that means. I don't have an academic. No. I already covered a couple of things. Yes, I said that. Of course, I did say that. Ideally, and yeah, it only works. I already mentioned that. The big difference is, though, you can only do this during the reprojection time, because then you can optimize. You can do that. But as soon as the application runs, you need to fall back to the traditional approach, where you just observe the events and start projecting them. But it really helps. I think we reduced like the upgrade time from, I don't know, 5 days to 6 hours or something, which is still too long, because we have big clients running software on oil platforms with a terabyte of data. I think only the event store is like 100 gigabyte, which is not super. It's like 55 million events or something. Probably there's bigger systems, but we're struggling with that. So that's one of the things. I have more. ORMs. Who has bad experience with ORMs? Who believes they just used it wrong and it's a great tool? See, these are the smart people. Even Alberto agrees. It's actually a pretty decent tool, ORMs. You just need to understand the pros and cons, like everything. What I like about it is that you still have the projection, and they just read the commits or the events in the way they appear in the event store. And then what you can do, you can process as many events as you want and then flush them in a batch. If you have a good ORM, you just load your projection from your ORM. You start to apply all the events. You have this unit of work that you get for free. And at the end, you flush it to the database. That's simple as that. And it's really fast. You know, I had like very senior architects saying, no, we should use raw SQL because it's always faster than an ORM. No, that's bullshit. There's particular cases where it completely makes sense. You can even mix, like raw SQL statements if you want to with the ORM provided thing. I'm still pretty fond of Hibernate in the .NET space, although the rest of the world moved over to anti-framework, which sucks. Oh, sorry, it's recorded. What else? Yeah, I mean, if you look at Hibernate, for example, it even offers second-level caching, which means if you load the same thing over and over again, it just works. You get like almost caching for free, lots of things that you don't have to build yourself. And what's the best thing as software developers, that you don't have to solve your problems yourself. You get it for free. What else? Yeah, okay. So if you do batching and all this stuff, you do have to handle like transient exceptions, like you start to flush a whole batch to database, something goes wrong, you might have to go back to smaller steps. That's something I solved in liquid projections, something within Hibernate. Those are the things you have to be careful of. So it adds a little bit of complexity, but it gives you speed. And yeah, of course, everything that you ran into in the past, you're still going to run into if you don't be careful. N+1 selects, lazy loading, you have to be very careful with that. But it's still a great tool. And again, every projector can take one of those things I showed you. Oh, it's all different. Okay, what else? Oh yeah, that's a bit of a picture of that. So this is what happens in the past. You know, we have these commits, and every time you apply an event, you do an insert or an update statement on the database, and then you have 6 of them. How many can we do in a second? You said something, 500 or something, yeah, rough. Yeah, if you're lucky. We're running in Azure SQL. And if you use an ORM, you essentially apply all these changes, and then at the end you flush it. At the end you tell your unit of work or your session or your DB context to flush it to the database. It's pretty simple. I think I showed this slide a couple of years ago. You can also go fully in memory. Like there's a projection that's not too big, doesn't contain too much data, and essentially at startup, you just project it into memory. It's just kept there. It's not persisted at all. It's still a projection. Probably needs to be asynchronous, but it can be asynchronous as well. Can be very fast. Again, depends how big is the projection. How many events do you need to process? And by the way, you can combine this with some of the other options you have. You can actually use well, you don't need to use an ORM, but yeah, it's a perfect valid solution. Can be both asynchronous. You could even use a distributed cache, because of course every serious application is scaled out. So if you don't want the reprojection to have in every application, so in every server, you could use a distributed cache, which is, of course, almost comes for free in the cloud, because the cloud solves all our problems for us. Yeah. But again, options, lots of different options. Yeah, sure. If you do this at startup, then it may take a time for that projection to be there, but maybe it's incredibly fast, much faster than users are actually going to use the system. It depends. Aggressive caching, I've used that also a lot. Works with everything, and MRU cache, most recently used cache. Essentially what you're doing is during the rebuilds, you rely on the MRU to really load your projection from the cache instead of from the database. And you could make that cache smaller, bigger. This is really a big kicker. It really improves the projection speed for us. Even though we're stuck to SQL Server because our clients use SQL Server in production, oil, gas, Equinor, one of the clients. But this works. This works, and there's plenty of options for MRU caches. I even used it in combination with RavenDB, also gave us a real performance improvement. Yeah, as I said. But you have to switch it off when you're done reprojection. And you can combine it with anything I showed you before, of course. Another thing is, instead of making it faster, reduce the amount of data to project. So you can actually say, you could mark certain streams as closed, and usually it's more complicated because you have streams that are connected, but you just reduce the amount of data to reproject. You could even have like a separate projector that kind of builds a graph, especially if you have aggregates that, although they are transactionally persisted and completely nicely modeled, and that never happens because all our models are wrong in the beginning. So in reality, you will probably have a couple of different aggregates that are supposed to work together. And you could build a graph that tracks like which aggregates or which streams are connected, and all of them are closed or done. The workflow is completed, or the state. I don't know if there's a closed state. It can project that separately, as I said. And then at the end, when this graph projector discovered, okay, now all the streams that are kind of functionally related are closed, we just mark in the event store all the streams as closed as well, or archivable, or some kind of terminology. Requires some extra metadata, by the way, which I probably have a balloon for. And you could do this either implicitly, like automatically, or you could trigger at some point, like have it done at a certain point, like when the domain is actually, if an entity gets closed, this projector will trigger itself by the closed event, obviously. Or you could say, like, after 5 years we do that, so all the data that's older than 5 years, we start to do that. But that really makes a difference, because then, if you do that, the projector on the left side can just skip all the closed commits or streams or events, which could make a big deal. Like, if I look at my own problem space, on average, if I look at data from 5 years, like 75% of the data is closed. So why would I reproject that? And 9 out of the projectors don't even need this data. That saves, and the beauty of that is that over time, the amount of active, non-closed streams kind of remains the same. That's, again, a nice solution. And again, you can combine all of that. They are all building blocks, see it like that. But yeah, your domain needs to have this notion of closed, obviously. And the metadata you need there, it should actually be here. I don't know which different event stores support that. We still use a very old library in .NET, and we can just extend our schema any which way we want. I don't know if event store supports adding. Yes, it does. I just heard from the source that it can do that. Maybe it even has this built in, I don't know. Maybe. But that's another nice solution. You could also build, if you really still need to be able to query the old closed data, build a separate set of projections. We've done that as well. Like basically a second set. So you have the one here, which has basically like a fixed schema, maybe with some, you know, some raw columns with JSON that have additional data that you don't want to search for. And the idea is you don't change that. And then you have the other one. And by the way, the projector is the one that kind of knows this. So the projector is smart enough to say, okay, now this stream is closed. I'm actually going to copy over the projection, which is technically just a record, you know, SQL or whatever, to the other table in a certain format. And then you only have to, you could even put it in a separate database, like in the cloud. You could put it there, like all the closed data doesn't have to be that fast when you search for it, but it's still available in the cloud. And then the open one only has to rebuild the open streams, as I said before. You just make it very explicit. Never has to rebuild, but it has some consequences. Yeah, again, of course, when the domain doesn't have a closed state. The only thing is that this persistent version, yeah, you have some limitations. You don't want to change the schema. You never want to update that, so you have some limitations how you search on that. But maybe that's obvious. Like in my domain, clients only use like a couple of fields for searching in closed data so that they can copy the item, and that works. Depends, again, options. Can you go further? Yes, probably, yeah. Oh yeah, and by the way, of course, if you have two different projections and you do want to present that as one thing, you have to join everything together, which is a bit of complexity you need to care of. But it's possible. We do that on SQL Server. Tombstoneing, have you heard of that one? It goes a little bit further. So instead of a closed set of projections, you basically create snapshots and you store them in, I don't know, Elasticsearch. I think you had it also in your picture somewhere. So you, at the point, I'll show you that in more details, but essentially you just create a snapshot, and because Elasticsearch or Solar or whatever, and Lucene even, RavenDB has Lucene built in, it's beautiful for searching. You just put the snapshot on, you tell it how you want to present the data, and that also solves kind of the versioning issue, like the new version of your code base has additional fields. Totally works. Totally works. And the rest is kind of the same thing. The projector, you have this specialized projector that takes the events and put them in the other one. I'll skip the bullets and I'll show you a little bit like what that could look like. So at some point, you mark a stream as archivable. Again, that's just a term that you can use, which the Tombstone projector will respond to because it's archivable. And again, you probably need something to track everything. That one will take a snapshot of your document by opening, loading the aggregate or the stream from the event store, creating an instance of your class like in .NET or Poco, create a snapshot out of it like a memento. It's a pattern, if you read the book. And that push that to Lucene or Elasticsearch locally in the cloud, whatever you have. And then it tells the document you need to tombstone yourself. What does the document do? It basically tells the event store to delete all its data, its history. It's all gone. Probably you want to track that, the fact that you did that, by having some kind of tombstone stream so that you can actually, like from an auditable perspective, figure out that what happened. Like, oh, my data's gone. What happened? It disappears. No, it was tombstoned. It's actually there. You can see that. There's a record of it. Like, it's event sourcing. We track everything with events, right? And then you have a normal projector, which used to have a projection, a persistent projection of that one, and it will respond to that stream tombstoned event and use that to actually clean up. And then the only thing is your application needs to be able to search through both different sources. The errors are not correct. They should go to the database. But you catch the drift, right? Kind of makes sense. This is also very powerful. We produce not just a snapshot, but for some clients we even produce a PDF of the thing. The thing that they normally see on the UI, we also produce the PDF because then they can put it on offline storage, like a DocumentDB or SharePoint, and then you will never find it back. All right, what's more? Yeah, this is also a nice one. This is something we've done this year. I discovered that cloning a table with 100 gigabyte of data in SQL Server is actually completes within 12 minutes on one of the smallest machines you can use on Amazon, for example. And I thought like, hey, that's interesting. Why would we reproject everything, but instead of just saying, you know what, we just clone the table and then continue with the projection from that point on. And we did a spike, and that proved to be very powerful. We managed to reduce the upgrade time from 5 days, really, 5 days of reprojection, to under 2 hours, and still have the blue-green thing. So that's interesting. I mean, yes, there's some limitations. I'll mention a couple of them. But essentially, the projector is autonomous. I like autonomous projectors. They can decide them for themselves when to reproject, how to reproject, how to handle exceptions, all of that. It's important. That one just says, okay, I'm new, and there's an existing database somewhere or a schema with an existing projection. I'm not going to start projecting from the first event all the way to the end. No, I'm just going to clone the table, and you can do that on the same database, for example, if you use SQL Server. As an example, you just clone the table on the same database. Then there's some scripts that you can use to clone also the indexes of foreign keys. If you're interested, I can share them with you. Took some time to figure that out. But the projector says, I'm cloning it, and then, and by the way, before I do that, I track the checkpoint of the source database, so I know from which point I need to reproject. Clone the table, plus all the other child tables if it's a big projection. You can do that in the transaction. And then you continue projection from that point on. And you can do that even while the old system is running. It really works. It's extremely powerful. And there's 2 flavors of that. The more simple one is you just clone the whole database. If you're in the cloud, it's pretty easy. You have a snapshot. You just say to the cloud provider, I want a copy of the database while the original one is still running. Don't rely on backpacks or anything on Azure because they're not consistent, we discovered in production. Yes, of course, the first Google hit that I got for backpacks was like, it's unreliable. Like, oh, crap. But I'm just a consultant, so I cannot be blamed. What I was saying? So yeah, the cheap solution is to just clone the entire database. Especially if you're in the cloud, there's tools for that. It's really fast because it's just a snapshot. And then you reproject. The more advanced scenario is every projector is responsible for cloning its own table. And it can also be very smart about it. And it could actually track the schema of that particular projection table and figure out whether cloning is necessary at all. Maybe nothing changed between the different versions. So you can go quite far with that and make it really advanced and fast. But yeah, performance adds complexity usually. Then what? Yeah, okay, I already mentioned that. And because the event store is still being used, the old system is still running, because you clone and then reproject and you can just catch on from the point where you cloned, the old system is still running. So it works with blue-green deployments. This is what we now call, instead of in-place and out-of-place upgrades, in-place on the same one by stopping the old system, or out-place where we build a new one, we call it side-by-side projections, because you're basically creating tables in the same database next to it. And you can roll back also. So if something goes wrong, you just roll back the old code version and it will talk to the old tables. Yeah, as I said, requires autonomy. The only flip side is if you're used to rely, and that's what happened in our code base, developers are used to be able to reproject everything. They treat projections, as Greg Young always explained it to me like many years ago with the same training, it's just a cache. So you're essentially saying, I'm going to retain the cache and do something smart. It's risky. Because if there's bugs in your projection, or people are used to the fact that we always rebuild the whole projection, you have to be aware of that. Again, complexity that you have to choose for. Yeah, and of course, because you can have any version of your projection schema in a database, your projector needs to understand how to upgrade the schema over time. That's extra complexity, but it's completely okay. We have anti-framework automatic, schema migrations, which I never understand. They always screw up everything. But it works. By the way, if you don't like to use anti-framework, use an Hibernate and Fluent Migrator, which is also beautiful for creating C# code, for example, to upgrade your schema. Another one is CopyOn write, which we use. So basically what you have is the new projection, you're actually not cloning anything. You just, whenever something happens, you create a copy of your projection into a new database with the new changes, and you keep the old one intact. Especially when you have projections that don't have complicated schemas with child tables and everything. If you use a SQL Server database, for example, it's a very powerful way of doing that. And again, like I said earlier, every projection has its own characteristics and can use a different solution that I mentioned from you. But yeah, that's what happens. So the old projection is not rebuilt at all. You just, whenever a new event comes in, especially if the new event is not part of the old code base, there's no data, you don't have to rebuild. There's nothing to reproject because it's a new event. You just copy it over and then update it, and you mark the old one as, well, you just leave it as is. And that's also one of the flip sides. So there's no rebuild needed. Searching, yeah, same thing. It depends what you use as a storage mechanism, because the old projection is never updated. You're not touching the schema at all. Because in our case, we want to be able to roll back instantaneously by putting the old binaries back. Again, same problem. You cannot rely on the rebuilds like you did. It's not a cache anymore, or it's a persisted cache. But you need to, and that's one of the more complicated things, both the new projection and the old ones will contain a version of that projection, both in the old schema and the new one. So you need to deduplicate the data, which is not that complicated. I mean, with SQL Server you can do that, and if it's a MongoDB or RavenDB, you can build a specific index for that does that for you. Now, we only talked about the projections, but what happens if your event store itself has a schema change? Because you are doing this closed, non-closed, and you have this extra column that you need to add to your event store, or you discover that your event store has the wrong structure, or you're even switching to a different event store provider. It's an option. It can happen. It happens in our case. Not too often, but it happens. Well, you can do two things, as you saw before. You can basically do a full out-of-place upgrade where you clone the entire event store table into a new copy, and then you do the projection work and use whatever techniques I showed you before. And that's what we do, we add some extra column, like a specific column to the event store. And this really allows you to do an in-place upgrade. The event store, every let's say commit or row in the event store has a version in there that represents the version of the code base. Which means if the new version of your code base roll out and is running in parallel for a while, everything that I just talked about applies there as well. You clone whatever, or you project, or you do clone and reproject, or you use MRU caches and everything. In our case, what happens is that after we do the upgrade, it's possible that in the first 48 hours after the new version is put in production, something really critical happened, we screwed up, there's a bug, and we need to be able to roll back. So rolling back by restoring a database backup is not an option. It takes too much time. So by making sure that all new events produced by the new code base is associated with the version of the code base, a software version or some other metadata, we can roll back because the old code base will never even see those events. It will filter them out. I want to only see the events up to a certain point. That will leave some residual data in the event store, which you can always clean up. But it literally allows us to drop the binaries of the old version, and everything still works. Yes, you will lose the data that was produced between the upgrade time, but that's in our case, it's completely acceptable. Because it doesn't happen that often. Usually we still do UATs and all that stuff, you know, these long-running processes, waterfallish. So most of the cases, the production issues don't appear. They only appear during the testing already. But it's an option. It allows us to really draw. And that creates also a sense of trust for the people that use our system. Like if you do an upgrade, especially if you're not running it yourself, but you deploy your event source system at an oil platform, at a big, I don't know, oil and gas company, that for them it's very important that the system runs. They can always roll back by putting the old binaries back, restart the thing, and everything works as expected. And we don't have these expensive upgrade times. Because as I said, a big database means we have a 100 gigabyte event store table, which I don't know if that's big for your standards, but I think it's quite big. Even in the cloud, creating a backup of a 100 gigabyte database takes some time, which is very powerful, and you can do that. I'm actually finishing early. Oh no, I'm exactly on time, I don't know. Yeah, I already mentioned that. Yeah, which is basically what I was supposed to be telling today. So different techniques that you can use, kind of a summary of everything I've run into, tried, or experimented with, and which we're using. And what I really like about it is that every solution can be applied on different problems. You don't need to solve all your production issues in the same way. There's different ways of doing it. That's probably also the reason why some of the libraries that are being talked about may be too dogmatic about it, or no, not dogmatic, sorry, opinionated. That's also why I typically see that Yeah, I don't use libraries that much. I will definitely look at yours and see if it makes sense for me, because there's so many variations that you need to deal with. The constraints that apply to systems, especially if you use event sourcing, I assume you have more complicated, distributed systems with a lot of collaborative users, because that's where event sourcing shines. You want to have that freedom to choose whatever technique works for you. And that's why I'm a little bit hesitant in using libraries myself, because they force you in a certain direction. I don't want to plug my own library because it's just a library building block, so you can use it any which way you want. Of course I can. But yeah, no, this is roughly what I had to tell. And the rest doesn't really make sense. Any questions? I have no clue how much time I have left. Yes? Which one, this one?
Yeah. So what is a code version? Can you give some examples?
So that's like we use Git flow as a release strategy. We use in .NET space Git version, which produces the number automatically. So typically we use the major and minor version of our code base, which is generated from the tags and the commits. Because for us, a hotfix, like the last part, the patch, would never touch any of the schema. That's not allowed. But minor versions actually introduce new functionality. So basically what says, the projector will look at the schema version, it's stored somewhere. If the, well, 10 minutes left, plenty of time to ramble on. So essentially it will look at the version. If the minor version or the major version is higher, it knows, okay, I have to do something, I have to reproject, I have to do something like that. If you can go one level further, well, that's for the event store, by the way. For projectors, every projector has its own schema version that it tracks. So it knows exactly, like when somebody makes a change to the projector that requires reprojection, it bumps a version and the code will actually know, I need to reproject that one.
So the code version, is it cover the entire application or is it the projector's code version?
No, for the event store, yeah, it's the bounded context version. Because, yeah, event sourcing is not something, it's not a top-level architecture style. Greg Young said that, like, has been saying that for the last, I don't know, 15 years. Everybody gets it wrong. We have, in our company, multiple domains. And some of the domains use event sourcing, and other domains don't use that. So it's kind of tied to the domain. But it's a number global to everything that uses that event store.
So that makes sense. It's domain-centric, and your projections probably need to be modified, but then they have ways of not reprojecting.
Yes.
Well,
it's not advanced that it can detect like based on events. It's more like the developer. If a developer introduces an event or changes the projection code in such a way that they know this requires some kind of reprojection, then it will bump the version. It puts it in the code. So, and that's why I love the autonomy. A projector should be autonomous and decide whatever, have all the knowledge and autonomy to make decisions on how it reprojects, when it reprojects, if it's synchronous, asynchronous. Because maybe a new version doesn't require that projection to be rebuilt.
Okay, so just so you reiterate, you say that hotfix, you don't need to reproject.
For hotfixes, we're basically saying you're not allowed, like if it's a hotfix, we should never reproject. Up to now,
because no change is safer just to rebuild.
Because we said like you should not do that. Hotfixes are binary replaced, but that's a decision that you have to make for yourself. That applies to our situation. Again, it depends. Yeah, sorry.
Well, that goes into what version you're moving, right? What part of Assembler are you implementing? And you can make that decision because you're the developer, you know what you
Well, yeah, I'm the architect, so we basically, I'm trying to repeat the question or at least answer it in such a way. But yeah, the point is that for us, we made a decision, it's a guideline, that if the major or minor version of the code base changes, that potentially requires a reprojection, or it's allowed at least. But if it's a hotfix, the patch, the third digit in a semantically versioned code base, that should never allow that kind of stuff. And we validate that, of course, also. Yeah. Does that answer your question?
Very well, thank you.
Okay, awesome. Any more questions? Yes.
Have you run into a time where you've parallelized your projection?
Have you run into a time where you've parallelized your projections? If so, can you tell us about it? And if not, why not?
So the question is, we always parallelize the projectors. Not all of them, but that's why I mean with asynchronous and autonomous, they just run in parallel. And
do you track so you mentioned the word checkpoint at the beginning. Do you then have to track checkpoints, at different points?
Every projector will need to check its own checkpoint. because it can also then decide how to reproject. Like if you do the cloning, it will track the checkpoint of the original table, clones the table, and then continues from that checkpoint, for example. But that's a requirement. If you make your projectors asynchronous, you need each... And that's beautiful, because we actually had issues where a transient exception in production caused the projection to screw up, and we basically deleted the table, just emptied the table, and then the projector would say, hey, I actually am empty. I'm going to start from scratch. So you have a lot of flexibility if you do that. So that's my default strategy, by the way.
I see. So does that mean that whenever you... So this seems like it would be really fast because you're parallelizing things. If you're not, projecting into a SQL database as well, then, you won't have a bottleneck there. Does that mean that then the next bottleneck becomes how quickly you can read from your event store?
Yes, that's true. And we never had any issues with the event store. Oh. Yeah, go ahead.
Subscription. I think Dennis talks about subscriptions running in parallel.
Yes.
Handling different checkpoints. You're talking about concurrent projections, which is a different thing.
Concurrent projections. You mean the same projector updating this, different projections at the same time?
No, it's like...
Okay, maybe we should take that offline then.
Yeah.
I don't want to confuse everybody. Like,
because I do that. It was freaking hard to implement. Yeah. So, but that's a different topic.
By the way, to optimize reading, we also use MRU caches. So we read pages of events from the event store, and we keep those pages in memory. So if a lot of different projectors are roughly at the same time, they will be very fast. They don't even have to go to the event store. But we don't always need it. Again, it depends on the characteristics of your system. Are you reading a lot? Have a lot of events. If you use the closed thing, you mark your streams as closed, and we can skip them. There's so many options that you can apply right now. And I at least hope in this talk that I give you some new ideas or tools or reinforced what you were already doing. So let's wrap up. I'll be around until 3 o'clock or something for all your questions and complaints. So thank you for having you here. And it was an honor to speak at KanDDDinsky again once more.